Hi everyone, I'm Henry F. Hauser Museum Curator Elizabeth Rozak.
And I'm NASA Solar System Ambassador Ted Forte.
And today we're here to tell you a little bit about the Webb Space Telescope, the largest and most sophisticated telescope ever to be launched, and about upcoming community events to spread awareness around Webb's capabilities.
So the James Webb Space Telescope will fundamentally alter our understanding of the universe. With its mirror that's almost 6 times the light grasp of the Hubble Space Telescope, Webb will be able to peer back further in time. We'll be able to see the birth of the first stars and the first galaxies. It will enable astronomers to understand how galaxies form and how they've changed over time. With its sophisticated infrared detectors, Webb will be able to see through dust to see the birthplace of stars and planets. And we'll be able to get an unprecedented look at the atmospheres of extrasolar planets and look for the indications of life on those distant worlds. The Webb will take about 30 days to reach its orbital position at the L2 Lagrange point. That's about 1 million miles from Earth. During that time, it's going to have to unfold like a piece of origami from a compact condition that it had to be to fit inside the fairing of an Ariane 5 rocket that will launch it into space, opening up to its full operational configuration. So its folded mirror will unfold and a tennis court-sized sun shield will deploy. The 18 hexagonal segments of the Webb's mirror will form into an almost circular reflective surface that's about 21 feet in diameter. That's 3 times the size of the Hubble's mirror, and yet it only weighs about half of what Hubble's mirror weighs. So the hexagonal segments are made of a metal called beryllium, which is extremely strong and very lightweight. It's covered with a light or a very thin coating of gold. The gold is necessary so that Webb can respond to infrared radiation. Now, Webb has to be very cold to operate in the infrared, and so a 5-layer sun shield made of a polymer called Kapton that's coated with aluminum will allow the telescope to passively cool to about negative 400 degrees Fahrenheit. 126 little motors behind the segments of the Hubble's or the Webb mirror will shape the mirror and keep it perfectly aligned. Once it arrives at the L2 Lagrange point, Webb will spend about 6 months doing calibration, collimation, and alignment of its mirrors and detectors. After that, it's 4 science instruments, each with their own array of cameras and spectroscopes and coronagraphs, will operate for about 5 years. The spacecraft does have enough fuel, however, to extend that mission to 10 years, and, well, astronomers actually hope for about a decade of discovery from the Webb Space Telescope.
To celebrate the launch of the Webb Telescope, the City of Sierra Vista is partnering with Patterson Observatory and Tuca Astronomy Club with support from NASA to bring great educational and recreational programming to our community. We're going to have programs like space-themed Rock and Roll at the Sports Division, a star party at Veterans Park, a Webb speaker presentation at the library, and a launch party at Patterson Observatory, which will also feature NASA artifacts. To learn more about these and other programs around Webb, you can follow the City of Sierra Vista on Facebook, visit our website at sierravistaaz.gov, or visit University South Foundation /community-events.
So thank you for joining us to learn more about the James Webb Space Telescope.
And you can join us all throughout October for some really out-of-this-world programming.